Welcome dear student and Jai Swaminarayan. In the previous video, we were discussed about the formation of covalent bond of the different carbon compounds and the formation of the covalent bond with the carbon compound with the other atoms. Now dear student, in this video, we will discuss about the formation of the very large number of the carbon compounds. When the carbon atoms are make a covalent bond with the very large number of the carbon atoms. Very large number of the carbon atoms are makes a covalent bond with the each other, forms the large number of the carbon compounds are formed. Different carbon compounds are formed, right? So let us start with the formation of the very large number of the carbon compounds, and that are called the allotropes of the carbon compounds, right? Carbon atoms. Now what do you mean by the allotropes of the carbon? Allotropes of the carbon, that means the carbon atoms are joined with the other carbon atoms in the different forms, right? The element carbon occurs in the different forms in the nature with the widely varying physical property, with the widely varying different physical properties. So when the carbon elements join with the different forms in the nature with the different physical properties, they are called the allotropes of the carbons, right? So here we are discuss the two allotropes of the carbon. The diamond and the graphite, right, are the two different allotropes of the carbon. So here in the figure, right, the structure of the diamond and the structure of the graphite are given, right? The here in the diamond, the carbon atoms join with the makes a covalent bond with the other four carbon atoms, right? And in the graphite, the carbon atoms are joined with the like this type of the ring structure, hexagonal structure, right? So the carbon elements are occurs in the different forms are called the allotropes of the carbon. So both the diamond and the graphite are formed by the carbon atom. The difference lies in the manner in which the carbon atom are bonded to one another, right? So one carbon atom are bonded to the how many carbon atoms they are form a allotropes of the carbon, right? In the diamond, each carbon atom is bonded to the four other carbon atoms, forming a rigid three-dimensional structure, right? So in the diamond, the carbon atoms makes a covalent bond. Carbon atom is bonded to the four different carbon atoms and it forms the three-dimensional structure. Like in the graphite, each carbon atom is bonded to the three other carbon atoms in the same plane, giving a hexagonal array, right? So in the graphite, each carbon atom is bonded to the three other carbon atoms in the form to form a hexagonal array. So these are the two allotropes of the carbon. One another allotropes of the carbon are a fullerene, right? In that the carbon atoms make a covalent bond with the other carbon atoms in the pentagonal structure, right? So these are the allotropes of the carbon. So carbon atoms are a very large number of the carbon atoms. It forms some different allotropes of the carbon, right? So understand dear student. Now formation of a very large number of the carbon compounds, right? The carbon forms a very large number of the compounds. The number of carbon compounds is a more than 3 millions. It is more than the number of the compounds formed by the other elements, right? So carbon forms the very large number of the compounds, more than 3 million, right? And it is a very large compared to the compounds formed by the other elements. Why? This is because of carbon atom can form a bonds with the other carbon atom to form a long chain, branch chain and close ring. This property is called the catenation. So carbon atom can form a covalent bond with the other carbon atoms to form this type of the long chain type of the structure. So long chain structure of the carbon like this, the carbon atom makes a covalent bond with the other carbon atoms in the form of the chain. So these are the chain structure of the carbon atoms, right? Long chain structure of the carbon atom. Carbon compounds makes a covalent bond with the other carbon compounds in the branch chain, right? Similarly, this carbon atom makes a covalent bond with this carbon atom. This carbon atom makes a covalent bond with this carbon. This carbon atom makes a covalent bond with this other carbon. So this type of the branch chain structure also formed by the carbon atom. And the carbon atom makes a covalent bond with the other carbon atom to form a closed ring type of the structure. Like this type of the 6 carbon atoms are joined, makes a covalent bond or bond with each other like this type of the closed ring structure, right? And because of this, the carbon compound has a more large number of the compounds, right? Carbon atom has a large number of the compounds, right? Now second reason is that since the valency of the carbon is 4, right, in the outermost orbit of the carbon atom there are 4 electrons are there. So we can say that the valency of the carbon atom is a 4. It can form a bonds with the other carbon atom or with the other atoms of the other elements like a hydrogen, oxygen, nitrogen, halogen, all the things, right? So the valency of the carbon is a 4. It can join, it can make a bond with the other 4 carbon atoms, or it can make a covalent bond with the atoms of the other elements like hydrogen atoms, oxygen atoms, nitrogen atoms, halogen atoms. So all this way the carbon compounds are formed. So carbon forms the very large number of the compounds because of these two reasons, right? So understand, dear student. So dear student, now we will see the carbon compounds, right? Different carbon compounds, hydrocarbons, right? First carbon compounds is the hydrocarbons. So hydrocarbons are the compounds containing the carbon and the hydrogen atoms, right? So what do you mean by the hydrocarbon? Hydrocarbons are the carbon compound in which the carbon atoms are mix a covalent bond with the hydrogen atoms, only hydrogen atoms. So the hydrocarbons are the compounds containing the carbon and the hydrogen. So there are two types of the hydrocarbons. First one is the saturated hydrocarbons and second one is the unsaturated hydrocarbon. So first of all, what do you mean by the saturated hydrocarbons? Hydrocarbons, you know, understand what do you mean by the hydrocarbons? Hydrocarbons are the carbon compounds containing the carbon and the hydrogen atoms. There are two types of the hydrocarbons. First one is the saturated hydrocarbons and second one is the unsaturated hydrocarbons. The saturated hydrocarbons are the hydrocarbons having the all single covalent bonds between the carbon atoms as well as all the single covalent bonds between the carbon atoms and the hydrogen atoms. For example, alkenes, right? Alkenes have all single covalent bonds between the carbon atoms and their name ends with the "ene", right? For example, if we consider the carbon atom, single carbon atom C, this single carbon atom has a 4 valence electron and these 4 valence electrons are makes a covalent bond with the valence electron of the 4 hydrogen atom, right? So carbon atoms makes a covalent bond with the 4 hydrogen atom. So these all the covalent bonds in the carbon atom are a single bond, right? So carbon atom makes a single bond with the other carbon atom and the hydrogen atoms, right? The hydrocarbons are known as the saturated hydrocarbons. Like this, C makes a covalent bond with the 4 hydrogen atom. The molecular formula of this is a CH4 and it is called the methane. The alkane names ends with the methane. Similarly, 2 carbon atoms, right, join with the 6 hydrogen atoms, right? This carbon atom join with the other carbon atom and other 3 electron of the first carbon join with the hydrogen. Other 3 valency of the carbon, second carbon is joined with the hydrogen. So C2H6, right? This molecular formula is a two carbon atom joined with the 3 hydrogen atoms, right? So this molecular formula C2H6 is called the ethane, right? So similarly, we can take the 3 carbons also, 4 carbons, 5 carbons, 6 carbons, and all the covalent bonds are hydrocarbons having a all the covalent bonds are a single covalent bond. So these are called the saturated hydrocarbons, right? To understand this one, what do you mean by the saturated hydrocarbons? So how many saturated hydrocarbons are formed? Number of saturated hydrocarbons are formed. So but you have to name the end with the A, like a methane. Second one is the ethane, right? So if the single carbon is there, the name is a methane. Single carbon makes a single covalent bond with the 4 hydrogen atom. 2 carbon connected with the covalent bond, and these 2 carbon makes a covalent bond with the 6 hydrogen atom. So molecular formula of the ethane is a C2H6. So number of hydrocarbons are formed, right? Try to make a structure of these hydrocarbons like a methane, ethane, propane, butane, pentane and hexane, right? Other is that certain octane, then all the things, but you have to remember only up to the hexane, right? So in the methane, the formula of the methane is a CH4. The carbon atom are makes a covalent bond with the 4 hydrogen atom. Ethane, the structure of the ethane formula of the ethane is a C2H6. The structure of the ethane is a carbon atom joined with the other carbon atom. Two carbon atom are joined with the single covalent bond, and the other valency of the carbon atom is satisfied with the 6 hydrogen atom. Similarly, if we take the 3 carbon atom, right, C3H8, so 3 carbon atoms are joined with each other, and the other valency of the carbon atom are fulfilled with the hydrogen atom. The molecular formula of the propane is a 3C3H8, right? Similarly, butane C4H10, similarly pentane C5H12 and hexane C6H14, right? So you can draw a structure of methane, ethane, propane, butane, pentane and hexane. Other is the septane, octane, henane, right? In that 7 carbon atom is there, 8 carbon atom, 9 carbon atom, 10 carbon atom, you can able, but you have to remember up to the hexane, right? So dear student, here all the carbon atoms and the hydrogen atom are joined with the are connected with the single covalent bond, and this all the type of the structures are called the saturated hydrocarbon. All the type of the hydrocarbons are called the saturated hydrocarbon. So now dear student, unsaturated hydrocarbon. What do you mean by the unsaturated hydrocarbons? Unsaturated hydrocarbons are the hydrocarbons having a double or triple covalent bond between the 2 carbon atoms, right? So in the between the 2 carbon, if the in between the 2 carbon atoms there are double covalent bond or a triple covalent bonds, the hydrocarbons are called the unsaturated hydrocarbons. For example, alkene and alkyne. Alkenes have a double covalent bond between the 2 carbon atoms, and their names ends with the "ene", right? If is there any 2 carbon atoms, there will be a double bonds between the 2 carbon atoms, they are called the alkenes, right? For example, if we considering a 2 carbons are connected with the double bonds, that means the 2 electrons of the carbon atoms makes a covalent bond with the 2 electrons of the other carbon atoms, and other 2 electrons of the carbon atom makes a single bond with the hydrogen atoms. Its a molecular formula is C2 and H4, and the name is a ethene, right? Similarly, if we considering the 3 carbon, and in between these 3 carbons, right, any 2 carbon are makes a any 2 carbon makes a double covalent bond between the carbon, either this one or this one, right? And other valency of the carbon is fulfilled by a hydrogen atoms, right? So here the C, 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 3 carbons, and between these two C, double bond is there. So other two valency of this carbon is fulfilled by a hydrogen atom. This carbon atom makes a covalent bond, 3 covalent bond, 2 covalent bond with this carbon and 1 covalent bond with this carbon, and other one electron makes a covalent bond with the hydrogen atom, and these carbon atoms makes a 3 covalent bond with the hydrogen. So here carbon atom is 3, but the hydrogen atom there are 6 hydrogen. So C3H6, and it is named called the propene, right? We can make a double covalent bond here also, right? So similarly, you can make a double covalent bond between a ethene, propene, right, butene, pentene, hexane, right? So you can make a double covalent, left one hydrogen here from here and makes a double covalent here. It is a propene, right? So you can make a alkene also, right? So alkenes have a double covalent bond between the two carbon atoms, and their name end with the "ene", right? Similarly, alkyne have a triple covalent bond between the two carbon atoms, and their name ends with the "ine", right? For example, ethyne. Ethyne, the molecular formula of the ethyne is C2H2. Two carbon atoms makes a triple covalent bond between the two carbon atoms, right? So the 3 electrons of the carbon atom makes a covalent bond with the 3 electrons of the other carbon atoms, but 1 electron is left. This makes a covalent bond with the hydrogen atoms, right? So the here the molecular formula of the C2H2, and that name is called the ethyne, right? Similarly, if you consider the 3 carbon atoms C, C and C, and first and second carbon atom join with the triple covalent bond, and the other carbon atom join with the hydrogen, it is a C3H4 propane. Similarly, you can form a structure like a propane, butane, pentane, hexane, right? This all the alkane, alkyne and alkyne. You can draw the structure, right? So understand, dear student, what do you mean by the hydrocarbons? Hydrocarbons are a compound formed by the carbon atom and the hydrogen atom. If the carbon atom and the hydrogen atom are having a single covalent bond, it is called the saturated hydrocarbon, and if the hydrocarbons having a double or triple covalent bonds between the two carbon atom, it is called the unsaturated hydrocarbons, right? So you can write the structure of the methane, ethane, propane, butane, pentane and the hexane. Similarly, you can write a structure of the unsaturated hydrocarbon ethene, propene, butene, pentane, hexene, right? So in this structure of the alkene, right, you have to make a double bond between the two carbon atoms. You can make a double bond between the any of the two carbon atoms, right? But you have to must satisfy the valency of the carbon atom, right? One carbon atom join the has the valency 4, right? Similarly, you can make a form of the alkynes, ethyl, propyl, butyl, pentyl, hexyl. In that, you have to make a triple bond between any two of the carbon atoms, right? So understand, dear student, all the saturated hydrocarbons and the unsaturated hydrocarbons, right? So here the hydrocarbons are joined in this type of the hydrocarbons, the carbon atoms are joined in a chain form, but the carbon atoms are joined with the branch form also, and that is called the isomers of the hydrocarbons, right? So what do you mean by the isomerism and the isomers of the hydrocarbon? The carbon compounds having the same molecular formula but the different structural formula are called the isomer, right? Isomers. This property is called the isomerism. For example, if we considering the butane, the molecular formula of the butane is a C4H10, has the two isomers, and they are normal butane and the isobutane. So if we considering the 4 carbon atoms are joined in this type of the chain structure like linear structure, and all other hydrogen atom are joined with the covalent bond with the carbon atom. So this type of the butane is called the normal butane. But if the 4 carbon atom are makes a covalent bond like a structure of this type of the branch structure, it is called the isobutane. So butane has a 2 isomers, right? Normal butane and the isobutane. Pentane has a molecular formula C5H12, has a 3 isomers, normal pentane, isopentane and the neopentane. So in the normal pentane, all the carbon atoms are connected in a chain structure, right? And the hydrogen atoms are attached, makes a covalent bond with the all the carbon atoms, right? That is the normal pentane. So here 4 carbons are connected in this, or one carbon is in the like this type of the branch, that is called the isopentane. Similarly, 3 carbons are connected in line and other 2 carbons are joined with the single central carbon. This one is the neopentane. So here the pentanes has a 3 isomers, right? So dear student, the carbon compounds are make a different type of the structural formula are called the isomers of the each other. So each the carbon compounds has a different isomers. How they are connected with the other carbon atoms are called the isomers of the carbon compound. So dear student, understand what do you mean by the isomers and the how we can draw the isomers of the different carbon compound. So now dear student, other carbon compounds, carbon atom joined with the oxygen, nitrogen, hydrogen, right? That we will see chlorine atom, bromine atom. So that we will see in the next video. Functional group. The carbon atom joined with the different functional group. How the carbon atoms are joined with the oxygen, how the carbon atoms are joined with the chlorine, that we will discuss in the next video. So dear student, keep watching my video.